April 30th, 1942. Royal Air Force, Duxford, England. Ronald Harker, chief test pilot for Rolls-Royce, climbed into the cockpit of Mustang IAM-121, an American-built fighter powered by an Allison V-1710 engine. The RAF's Air Fighting Development Unit had invited him to evaluate this new American aircraft that British pilots were praising enthusiastically for low-altitude operations. Harker took off and immediately felt impressed. The Mustang accelerated smoothly. Controls were responsive. Visibility was excellent. At 5,000 feet, the aircraft performed beautifully, fast, maneuverable, stable. He climbed to 15,000 feet, still excellent. Then he pushed higher. At 20,000 feet, the Mustang began struggling. Power dropped noticeably. Climb rate deteriorated. By 25,000 feet, the aircraft felt sluggish, almost reluctant to respond. Above 30,000 feet, where German fighters operated routinely, the Mustang was nearly helpless. Harker landed and filed his report to Rolls-Royce. The aircraft is magnificent below 18,000 feet. Above that altitude, it's useless for air combat over Europe. The Allison engine simply cannot perform at high altitude. Then, Harker wrote something that would change the war. However, if this airframe were fitted with a two-stage Merlin, it would be an outstanding fighter at all altitudes. Nobody in authority listened. Nobody with decision-making power took action. Except one man. Lieutenant Colonel Tommy Hitchcock, Jr., Assistant Military Air Attaché at the American Embassy in London, read Harker's report and realized what it meant. The P-51 Mustang, dismissed by the U.S. Army Air Forces as unsuitable for combat, could become the war-winning fighter if someone had the courage to defy conventional wisdom and install a British engine in an American airframe. Hitchcock began sustained lobbying at the highest level without official authorization. He bypassed channels. He ignored protocol. He pushed an engine swap that violated procurement rules, challenged American pride, and threatened careers. And he was right. Within 18 months, the Merlin-powered P-51B would achieve 441 miles per hour at 30,000 feet, nearly 100 miles per hour faster than the Allison-powered version at that altitude. By war's end, Packard Motor Company would produce 55,533 Merlin engines, transforming American air power and enabling the daylight bombing campaign that crippled Nazi Germany. The North American P-51 Mustang was born from desperation. In April 1940, the British Purchasing Commission approached North American aviation with an urgent request. Britain needed fighters immediately. Could North American build Curtiss P-40s under license? North American's chief designer, Edgar Schmood, made a bold counterproposal. Give us 120 days and we'll design a completely new fighter superior to the P-40. The British, desperate for aircraft, agreed. On October 26, 1940, just 102 days after signing the contract, the NA-73X prototype flew for the first time. It was an engineering miracle. The Mustang featured revolutionary aerodynamics, a laminar flow wing designed by NACA, the National Advisory Committee for Aeronautics, that reduced drag dramatically. The radiator was positioned beneath the fuselage in a carefully designed scoop that actually added thrust through the Meredith effect. Heat from the cooling system accelerated airflow, providing forward propulsion. Performance at low altitude was spectacular. The RAF began receiving Mustang 1s in late 1941 and immediately deployed them for tactical reconnaissance and ground attack. Pilots loved the aircraft's speed, range, and maneuverability below 15,000 feet. But above 18,000 feet, the Mustang became mediocre. The Allison V-1710 engine, designed for low-altitude operations, simply couldn't produce adequate power in the thin air where German fighters operated. The single-stage, single-speed supercharger was inadequate for high-altitude combat. The U.S. Air Forces concluded the Mustang was unsuitable as a frontline fighter. Too slow at altitude, can't escort bombers, relegated to ground attack and reconnaissance, focused development resources on the P-38 Lightning and P-47 Thunderbolt instead. The decision seemed rational.
The P-38 could reach 44,000 feet. The P-47 was heavily armed and armored. Why invest in a fighter that couldn't compete above 20,000 feet? As Hitchcock would later write in frustration, sired by the English out of an American mother, the Mustang had no parent in the Air Force to appreciate and push its good points. The Mustang was orphaned, forgotten, dismissed, until Ronald Harker flew it and saw what nobody else could see.
In April 1942, Wing Commander Ian Campbell Ord, commanding officer of the RAF's Air Fighting Development Unit, invited Harker to test the Mustang. Campbell Ord suspected the aircraft's poor high-altitude performance was engine-related, not airframe-related. Harker flew the Mustang for 30 minutes and confirmed the hypothesis. Below 18,000 feet? Excellent. Above 18,000 feet? Disappointing. The problem wasn't the airframe, it was the power plant. Harker returned to Rolls-Royce's facility at Hucknall and consulted with chief engineer Witold Chelier. They did aerodynamic calculations, estimating that installing a two-stage Merlin 61 would give the Mustang a maximum speed of 441 miles per hour at 25,600 feet, performance that would exceed the Spitfire 9 in some respects. The numbers were extraordinary. A simple engine swap could transform an average high-altitude fighter into a world beater. Rolls-Royce began converting 4 Mustangs to Merlin power at Hucknall in June 1942. The first conversion, AL-975, received a Merlin 65 and a 4-bladed rotor propeller. Engineers worked frantically, modifying engine mounts, installing a larger radiator to handle the Merlin's greater cooling requirements, and adapting the airframe to accommodate an engine that weighed 300 pounds more than the Allison. The first Mustang X flew on October 13, 1942, with Captain R.T. Shepard at the controls. The results were spectacular. Trials completed at the end of December demonstrated that the re-engined fighter's performance, especially at high altitude, was extraordinary. But the RAF couldn't proceed with large-scale conversion. Rolls-Royce's Merlin production was already allocated to Spitfires, Lancasters, and Mosquitoes. Britain simply didn't have spare engine production capacity for American fighters. The solution would have to come from America, and that meant overcoming American institutional resistance to using a British engine.
Lieutenant Colonel Thomas "Tommy" Hitchcock, Jr. was perhaps the most remarkable American officer most people have never heard of. Born February 11, 1900, in Aiken, South Carolina, Hitchcock began his military career during World War I at age 17 with the French Lafayette Flying Corps after the U.S. Army turned him away for being too young. He earned his wings with the French, scored 3 aerial victories, then was shot down by Germans and captured. After 6 months as a prisoner of war, Hitchcock escaped, jumping from a moving train and walking more than 100 miles to safety in Switzerland. After the war, Hitchcock became one of America's most renowned polo players, aggressive, hard-charging, relentless. He brought that same intensity to every challenge he faced. When war returned in 1939, Hitchcock volunteered immediately. After his appointment as Assistant Military Air Attaché in London in 1942, Hitchcock reported to Washington on the results of British tests involving the P-51A airframe and the Rolls-Royce Merlin 61 engine. He visited Hucknall, he flew the Allison-powered Mustang, he examined the test data from the Merlin conversion, and he understood immediately what this meant. America had the airframe for a war-winning long-range escort fighter. Britain had the engine. Combining them was obvious, except it wasn't obvious to anyone in Washington. The U.S. Army Air Forces had invested heavily in the P-38 and P-47. Switching to a British engine for an American fighter would be politically embarrassing. It would undermine confidence in American engine manufacturers. It would require retooling production lines, negotiating licensing agreements, and admitting that American engines were inferior at high altitude. Hitchcock became relentless. The word channels, like the word no, was an utterance he sometimes could not hear well, his biographer Nelson W. Aldrich Jr. observed. He planned on going straight to the top. Hitchcock flooded Washington with test performance statistics from the British Merlin conversions. He wrote memoranda emphasizing the Mustang's potential. He hosted parties in London for well-connected friends, drumming up support for the Merlin-Mustang combination. And critically, he bypassed official channels.
In November 1942, Hitchcock flew to Washington and called on an old friend from World War I, Robert Lovett, Under-Secretary of War, one of General Henry Hap Arnold's civilian bosses. Lovett, who had flown British planes during World War I, agreed with Hitchcock's assessment. He pressed hard for Arnold to adopt the Merlin-powered Mustang. General Arnold resisted. Arnold believed deeply in American technological superiority. The ultra-secret Norden bomb sight would allow precision daylight bombing. American heavy bombers, B-17s and B-24s, wouldn't need long-range escorts because they were invincible. "We just closed our minds to long-range escorts," General Lawrence S. Cooter, a deputy under Arnold, admitted after the war. "We couldn't be stopped. The bomber was invincible." Reality was destroying that theory. Unescorted B-17 and B-24 heavy bombers could not protect themselves against enemy fighters. No American fighter had the range to accompany bombers deep into enemy territory. Nearly 75% of bomber crewmen were killed, severely wounded, or captured in 1943 alone. Lovett used those casualty figures to hammer Arnold. How many more bomber crews had to die before the Air Forces accepted reality? The Mustang with a Merlin engine could escort bombers to Berlin and back. No other fighter could do that. Arnold reluctantly acquiesced, ordering approximately 2,200 P-51Bs in late 1942. But even before Arnold's order, events were moving forward. North American Aviation, fully briefed by Rolls-Royce on the Mustang X project, had started planning their own Merlin-powered Mustang. In August 1942, the USAAF ordered 400 P-51Bs, gambling that they would prove everything hoped for them before any Merlin-engined Mustang had flown. This was extraordinary. The military ordered production before testing. That only happens when someone with power is absolutely convinced the gamble will succeed. That someone was Tommy Hitchcock.
Installing a Merlin in a Mustang wasn't simple. The British engine had been designed using imperial measurements. American manufacturing used different standards. Rolls-Royce built engines with tolerances that required skilled craftsmen to hand-fit components. American mass production demanded interchangeable parts. In September 1940, the British government had placed a $130 million order with Packard Motor Car Company to manufacture Merlins under license, originally to supply Britain, not America. Henry Ford had initially offered to build Merlins, then rescinded when he learned they were for Britain. In July 1940, Henry Ford stated he would manufacture only for defense, not for Britain, and the entire deal was declared off. Packard accepted the challenge. The first Packard-built engine, designated V1650-1, ran in August 1941. But that first engine was a single-stage Merlin 20X, suitable for bombers and low-altitude fighters. What the P-51 needed was the two-stage, two-speed supercharged Merlin 60 series, specifically the Merlin 61 with its complex two-stage supercharger that maintained sea-level power output up to 30,000 feet. The two-stage Merlin featured two separate impellers on the same shaft, normally driven through a gear train at a ratio of 6.391 to 1.
A hydraulic gear change arrangement could increase this ratio to 8.095 to 1 in high-speed blower position. The supercharger was a technological marvel. It compressed incoming air in 2 stages, with an intercooler between stages to prevent detonation from excessive heat. Without the intercooler, compressed air temperatures could exceed 400 degrees Fahrenheit, causing engine-destroying pre-detonation. Packard engineers had to adapt this complex British technology for American mass production. They modified bearing materials, switching from copper-lead alloy to silver-lead combination with indium plating, a development from GM's Pontiac division that prevented corrosion and improved load-carrying ability. The most significant improvement, Packard incorporated the Wright supercharger drive quill, which improved reliability dramatically. This modification was designated the V1650-3 and became known as the high-altitude Merlin, destined for the P-51.
North American Aviation's XP-51B, company designation NA-101, flew for the first time on November 30, 1942. NAA test pilot Bob Chilton took the aircraft up to 29,800 feet. The performance was astonishing. Chilton achieved a level speed of 441 miles per hour at altitude. The XP-51B could climb almost twice as fast as an Allison Mustang. Compare that to the Allison-powered P-51A, approximately 390 miles per hour at 20,000 feet, deteriorating rapidly above that altitude. At 30,000 feet, the Merlin-powered Mustang was nearly 100 miles per hour faster than the Allison version. The speed advantage was just part of the story. The Merlin's fuel efficiency transformed the Mustang's range. The P-51B initially carried about the same fuel as the P-47 Thunderbolt, but got 3.3 miles per gallon while the P-47 got less than 1.8. Brigadier General Thomas "Tommy" Hayes, a Mustang ace, summarized it perfectly. The Merlin-powered P-51 had the 3 qualities you need most if you are going to escort bombers to Berlin: range, range, and range. By early 1943, production was ramping up. North American's Inglewood, California plant began producing P-51Bs. A massive new plant in Dallas, Texas, originally built for trainers, was retooled to produce P-51Cs, identical to the B model, but built in Texas. The RAF ordered 1,000 P-51Bs, designated Mustang III, in British service. The gamble had paid off. Hitchcock's unauthorized advocacy, his relentless lobbying, his refusal to accept no, all of it had been vindicated. Of the approximately 150,000 Merlin engines built worldwide during World War II, Packard manufactured 55,523 in the United States. Think about that number. 55,523 complex aircraft engines, each containing over 14,000 parts, each requiring precision manufacturing, each needing to perform reliably at altitudes where temperatures dropped to minus 40 degrees Fahrenheit and air pressure was 1/3 of sea level. Packard achieved this through mechanized production and low-tolerance, highly interchangeable parts, something Rolls-Royce couldn't match in Britain. Packard sold 98,000 automobiles in 1940 alone. It was a luxury automaker operating at industrial scale that dwarfed Rolls-Royce. When war came, Packard converted that mass production expertise to military engines. Early Rolls-Royce Merlins had been partially hand-built, with craftsmen filing components to fit. Packard's modern industrial processes created parts so precisely manufactured they were genuinely interchangeable, critical for field maintenance where mechanics couldn't hand-fit components. The production rate accelerated as the war progressed. Initial engines took weeks to build. By 1944, Packard was completing engines in days. The V1657, the ultimate Packard Merlin, producing 1,695 horsepower,
became the standard power plant for the P-51D, the most produced variant. Most Packard Merlins powered P-51 Mustangs, but they also equipped P-40F Warhawks, earlier models, Canadian-built Hawker Hurricanes, and British Avro Lancaster bombers through Lend-Lease. The engines were so well built that in 1963, nearly 20 years after the war, Rolls-Royce still honored the warranty on Packard-built Merlins, telling a P-51 owner who needed a clutch repair, "Rolls-Royce designed products do not fail. They may require occasional adjustment, but this is covered by our unlimited warranty. So there is no charge, sir."
By late 1943, P-51Bs began reaching combat squadrons in England. The 8th Air Force, bleeding from unsustainable losses to unescorted bomber formations, received the Mustangs with desperation. In December 1943, P-51s flew their first long-range escort mission. The results were immediate and dramatic. German fighters, accustomed to attacking bombers without effective opposition above 25,000 feet, suddenly faced American fighters that could match their altitude performance and outrange them. In March 1944, with Mustangs escorting the first U.S. daylight bombing raids on Berlin, the fighter Hitchcock had championed achieved the potential he had envisioned all the way back in 1942. The strategic implications were profound. Without long-range escorts, the daylight bombing campaign had nearly collapsed. Bomber casualties in 1942-43 were catastrophic. The odds of a B-17 crewman surviving 25 missions were only 1 in 4. The Merlin-powered Mustang changed that calculation. Bomber losses dropped as P-51s decimated German fighter formations. Luftwaffe pilots, who had enjoyed near impunity attacking unescorted bombers, now faced an opponent that could follow them anywhere and win. Colonel Clarence E. Anderson, a Mustang ace, wrote that the aircraft went like hell because the Merlin had great gobs of power and was equally at home, high or low, thanks to its 2-stage, 2-speed supercharger. By D-Day, June 6, 1944, Allied air superiority over Europe was absolute. The Merlin-powered Mustang had made that superiority possible.
On April 19, 1944, Lieutenant Colonel Tommy Hitchcock was killed when his P-51B suffered structural failure during a high-speed dive over England. The problem: wings occasionally fell off P-51Bs during high-speed dives. Investigations revealed that wing ammunition doors or main landing gear could open under high-G conditions, producing excessive forces on the wing. Hitchcock, who had done more than any other individual to make the Merlin Mustang a reality, died in the fighter he had championed, killed by a structural defect that would be corrected within months. He did not live to see how the P-51 Mustang contributed to the Allied air supremacy that was prerequisite for the successful invasion of Normandy 2 months later. But by the time of his death, Hitchcock had seen his vision vindicated. Merlin-powered Mustangs were escorting bombers to Berlin and back. German industrial capacity was being systematically destroyed. The air war was being won. And it was being won with an American airframe powered by a British engine that one relentless American officer had forced through institutional resistance, bureaucratic inertia, and nationalist pride. The numbers tell the story. 55,523 Packard Merlin engines produced. 15,586 P-51 Mustangs built. Approximately 4,950 German aircraft destroyed by P-51s. 75% bomber crew casualty rate in 1943 reduced dramatically after Mustang deployment. But statistics don't capture what Tommy Hitchcock accomplished. He saw a solution that experts missed.
He advocated for it when authorities dismissed it. He bypassed official channels when necessary. He leveraged personal connections shamelessly. He refused to accept institutional answers. As historian Donald Miller wrote, the Merlin-powered P-51 could go as fast and as far as the bombers without losing its fighting characteristics. It was the plane the bomber mafia had claimed was impossible to build. The transformation was complete. The P-51A with Allison, 390 miles per hour at 20,000 feet, limited range, unsuitable for bomber escort. The P-51D with Packard Merlin V1650-7, producing 1,695 horsepower, provided the U.S. Army Air Forces with a high-performance, high-altitude, long-range fighter that could escort heavy bomber formations all the way to Berlin and back. Post-war analysis concluded that without the P-51 Mustang, the daylight strategic bombing campaign might have been abandoned. Without that bombing campaign, D-Day might have been postponed or failed. The war might have lasted years longer. All because one pilot saw what bureaucrats couldn't see, that combining American manufacturing with British engineering would produce a weapon greater than either nation could build alone.
The story of the Merlin Mustang is the story of how nationalism nearly prevented the war's most important fighter from existing. American officials resisted using a British engine because it undermined national pride. British officials couldn't spare Merlin production for American fighters. Both sides had valid concerns. Both sides were wrong. Tommy Hitchcock understood what policymakers didn't. War doesn't care about pride. War cares about results. The P-51 with an Allison engine was mediocre. The same airframe with a Merlin engine was magnificent. The difference wasn't American manufacturing versus British manufacturing. It was the right engine for the mission requirements. The Merlin 60 series, with its two-stage, two-speed supercharger, maintained power output at altitudes where single-stage engines suffocated. No American engine in 1942 could match that performance. Pretending otherwise killed bomber crews. Hitchcock's legacy is that he forced institutions to face reality. He made the uncomfortable argument that American engines weren't adequate for the mission. He advocated for British technology in an American fighter. He did it knowing it would offend people, damage relationships, and possibly end his career. He did it anyway because it was right. And 55,523 Packard Merlin engines later, nobody could argue with the results.
Packard V1650 Merlins remain heavily used today in drag racing, hydroplane racing, and land speed racing at places like the Bonneville Salt Flats. The Mynarski Lancaster, flown by the Canadian Warplane Heritage Museum in Hamilton, Ontario, one of only 2 Lancasters flying in the world, uses 4 Packard Merlin engines. Warbird enthusiasts continued developing even more power for Merlins for unlimited-class racing at Reno. Innovations include using Allison V1710 connecting rods and replacing intercoolers with water methanol injection to boost output beyond 3,000 horsepower. Every year, surviving P-51 Mustangs perform at air shows worldwide. The sound of a Packard Merlin at full power, a deep, throaty roar that resonates in your chest, reminds audiences of when these engines powered the fighters that won air supremacy over Europe. But the real legacy isn't in museums or air shows. It's in the principle Tommy Hitchcock demonstrated. Sometimes the most important thing you can do is break the rules. Not recklessly, not selfishly, but when you see a solution that authorities dismiss, when you understand a truth that institutions deny, when lives depend on doing the right thing regardless of regulations, that's when breaking rules becomes duty.
Tommy Hitchcock saw that combining a British engine with an American airframe would save thousands of lives. He advocated for it without authorization, he bypassed official channels, he leveraged personal connections. He made enemies. He didn't care. Because 55,523 Packard Merlin engines later, the results proved he was right. And that's the lesson. The best weapon in the world means nothing if pride prevents you from building it.